So I will explain you the manual of ACS 310 drive. So let's start. So first, what we will discuss. So I will not go explain you all the manuals, but the some of the main points so that you can start. The first thing, I will go with the power connection and the control interfaces. So here you can see all the connection points of the ACS drive. So SCR, okay, and then AI1 and the ground and then 10 volts. So there is a lots connections there. There is a points where we will connect the wires. So SCR stand for the sealed cable. The sealed cable for the sensors we will connect over here. AI stand for analog input 1, in which we will connect our analog input, okay, and this is the ground for that analog input. And for the fourth pin, as you can see, the fourth pin is 10 volt power supply, okay. There is a limit that we can take only 10 milliamperes, okay, current from this 10 volt. And the other thing is AI2, that is analog input 2, and this is the ground for that analog input. Same way, there is a 24 volt output, and the limit of this output is 200 milliampere max, and this is the ground for this 24 volt DC output. And this is the digital common pin for this digital input. 5 pins is there. This is the common for digital input pins, okay. And this is 23 to 26 is RS485 connections, okay. There is a 23 is the sealed, 24 is the B, means positive, 25 A negative, 26 ground, okay. And at last you will find U1, V1 and W1. These are for the inputs, and U2, V2 and W2 are the outputs where we will connect our motor. And there is a 6, I will show you this point, 6 where we can connect an output extension module, means a relay module. Suppose if we want a more relay, because in ACS 310 we have only one relay, okay. So if we want more relay, so we have to connect an additional relay module, okay, for this purpose. So we will connect over here, okay. Next, there is a one relay module, that is 17, 18 and 19, in which 17 is the common pin and 18 is NC and 19 is NO pin, okay. There is a rating for this relay as well as there is a limit is 250 volt AC and 30 volt DC and 6 ampere max current we can pass through this relay, okay. And there is also one more pin, more relay. We can use this pin as a relay also, but we can connect as a digital frequency output also, okay, and PMP transistor type also. So there is a 20, 21 and 22 pins, in which the out pin, this is the ground pin and this is the output pin. We can take the input from here and we will take the output from 21, okay. And this is the EMC filter and various grounding, okay. So in page number 25 you can check all the points are in ACS 310, okay. And now we'll move to page 49, okay. Now here you can see all the pins. Total pins are 26, as you can see here. So in which these pins are named as, tagged as X1A and X1B and X1C, okay. There is total 26 pins there, okay. So the main thing is here, these AI1 and AI2. There is a 2 dip switches here, okay, 2 dip switch. So why we use this 2 dip switch? So let me explain. As you can see over here in the last, switch S1, if you want analog input as a voltage, okay, you have choice. You can choose analog input as a 0 to 10 volt as well, and also 0 to 20 milliamps, okay. So if you need, as per your need, you can turn on this dip switch and off. Suppose this first for analog input 1, default is this, okay, minus 20 to 20 milliamps. But if you want this pin to use as a 0 to 20 milliamps, you have to make it on the top, okay. Same like here for this analog input pins, okay. So let me show you. There's 2 dip switches there, okay. I will explain you this in upcoming sessions, no problem. And also there is a J710, okay. There is a termination resistor is there. When you want to connect 2 or 3 drives for in RS485 communication cable, so if you want to control all the drives from the PLC, you have to use this termination cable. So in the 50 you can see how you can connect a voltage and a current output and in analog input. So if you want to connect voltage, you have to perform like this. If you have the current, you have to perform like this. Okay, so let's move. This is the main thing. Where how you want to control your digital pins, whether by using PNP or NPN. Okay, PNP is also known as source and NPN is known as sinking. Okay, so as you can see here, in PNP source means you are supplying 24 volts. See, this 24 volt is supplying through 9 to all the digital input pins. So if you are supplying 24 volt to your digital pins, it is called as PNP or source. And if you are supplying ground, so this ground from 10 we are supplying to all the digital inputs, then it is known as NPN or sync mode. Okay, so let's move to another 52. There is also some details over 52. This is the 52. Okay, so this is the default IO, default micro for this ABB 310. Okay, this is the default macro. I will explain you this in details later. But as you can see, this is what is the default connection is here. This is the sealed cable. Okay, analog input from 0 to 10 volt. Okay, this is the analog input. This is ground and this is 10 volt. So as you can see, this 10 volt and this ground is taken by this box. So this box is nothing but a potentiometer. This box is nothing but a potentiometer, and this potentiometer is supplying to this analog input. So based on the value, so potentiometer will provide between 0 to 10 volts. Based on this value, speed of the motor will vary. Okay, and here you can see output, analog output. Okay, so as you can see over there is a meter over here, so through this meter we can read the output frequency or output speed. We can read whatever we want. Okay, there is one analog output pin. Okay, in the analog output pin we will get only 0 to 20 milliamps, but in case of analog input, we can decide whether we want to supply 0 to 10 volt or we want to supply 0 to 20 milliamps. But in case of analog output, we will get only 0 to 20 milliamps as a output current. There is no option to get 0 to 10 volts. But I will show you, if we want a 0 to 10 volt, how we can get a 0 to 10 volt from this analog output pins. Okay, and this is the ground for this analog output, and this is 24 volts which we are giving to our digital output pins, digital input pins, and also to the relays also. Okay, as you can see here, from DI1 it will, if we give 1, if we provide the voltage over here, means if we turn this switch on, this switch, so the motor will start. If there is no power, motor will stop. Okay, if the DI2 is 1, it will move in reverse direction, but if it's 0, it will move to forward direction. In the DI third, if it's on, there is a constant speed 1. Constant speed 1 means we can set what speed we want. Suppose 30%, 40%, 50%. Same way DI4 we can use as a constant speed. Suppose if we press this DI4, so we'll get a speed, constant speed 2. Suppose we set as a for this constant speed we set at 60%, and for this we can set 80%, 90% as our need. Okay, and this is the acceleration deceleration selection. Okay, so let's move to the parameter. As you can see over here, if you are connecting more than one drives, so you can use this J701 resistor, termination resistor is there. So how you can connect? There is a pin, this pin 23 to 26. This pin, through this pin we can connect our drives. Okay, all the drives we can connect through these pins. Okay, so what you have to do, take a wire, 4-core wire, and connect all SCRs together. Same way connect all B and all A and all ground pin. Okay, in a DC chain, means from here to here, and then from here to here, and then from here to here up to your PLC or BMS system. Okay, but you have to take care about this one. If there is a last VFD, see this drive is the last. Okay, so at last you have to terminate this resistor. Okay, how? As you can see, there is 2 pin in J701. There is 2 pin, 1 pin and 1 pin 2. So you have to sort this 2 pin from what beside this one, also 2 pin you have to sort, and the 2 pin you have to left that one. But in the others VFD, what you have to do, you have to make like this. You have to sort in Here you are sorting in horizontal, okay, but here you have to sort vertical, but you have to leave top two empty. Here bottom two are empty, okay, there is no sorting. But in the other for the others you have to sort the bottom two, but you have to leave the top one empty. Okay, so let's move to startup. Okay, let's move to our startup. So once you power up the VFD, once you power up, you have to set some manual startup. Okay, manual startup means you have to set the motor data so that you can check whether it's working fine or not. So for the manual entry startup, you have to go to parameter 99 group. In the parameter 99 group, you can set what is the voltage range. As you can see here, what is the voltage range. Okay, same like you can set what is the current. Okay, what is the motor nominal current, what is the motor frequency is there, what is the motor speed is there, what is the motor power means kilowatt is there or HP is there. So you have to set these things. Once you finish this thing, you can run your motor. But once you run, maybe you will get a problem that the motor is moving in other direction, means in reverse direction. So if the motor is moving in reverse direction, what you have to do, you have to go the parameter 9914. Okay, and this 9914 is a phase inversion, means if you went to 9914, there is it will show you a value either 0 or 1. If it shows 0, you have to make it 1. If it's showing 1, you have to make it 0. Once you make it inverse, your motor will move in forward directions. Okay, so let me move the other. Okay, here in the screen, as you can see, there is a lots of buttons there in the display. So this button is exit button. Okay, this is the enter button. Okay, this is for up down. This is up down key. Up down key, through up down key we can increase or decrease the value. Okay, this is the local remote button. Okay, if we press one time, it will go to local, and if you press it again, it will go to remote. From local we can control the motors from display itself, but if you want to control from remotely, from the BMS, from the PLC, or from the input output pins, okay, you have to go to remote. Okay, if you are in remote, you are not able to control the motor from the display. Instead, you have to control it either from PLC, either from BMS, or you can control it from the buttons. Push button means digital input pins. Okay, in the display, it will show you 4 things in the display. Okay, like A, B, as you can see, 1A, 1B, 1C, 1D, 1E. Okay, here you can see A means upper left. What it will show? It will show you the local or remote. In the upper B means this section, it will show you the unit. This is ampere for amps, voltage for volt, frequency for F, like this. Okay. In the D section over here, it will show you the it will show you the mode, either in output mode or parameter mode or main mode or fault mode, main mode or fault mode. Okay. In the E section, you will see either the motor is in forward direction or in reverse direction. Okay, reset and exit. This is your exit or reset. This is your enter pin. Okay, this is the direction. Change the direction of the motor. Okay, this pin, from this button you can change the direction of the motor. If it's moving forward, you can make it reverse. If it's moving in reverse, you can make it forward. Okay, so, and there is 2 buttons, start and stop. Through a stop button you can stop the motor, and from the start button you can start the motor. So let's move to another. Okay, 74. There is a 3 or 4 modes is there. In output mode, we can see the output. Output means the monitoring value. We can check up to 3 monitor value in the screen. Like if the motor is running, we can check 3 details, 3 outputs of that motor. So we have to decide what we want to see. So by default, we can check the frequency, the amperes, and the speed. Okay, but if you want to manipulate this value, you can change the value, whatever you need. Okay, so in the output mode, you can check the output of the motor. Okay, current output of the motor. Okay, same way in the reference mode. In the reference mode, what you can do, in the reference mode, you can run the motor from the display. If you want to check whether what your program is working fine or not, you have to go to local mode and then set the reference. Okay, set the frequency. Once you set the frequency, just press the start button, the motor will start. Okay, and the next mode is parameter mode. Through the parameter mode the whole programming is done. Okay, we can set the motor data and whatever program we want we can set from here, the parameter mode. Okay, this is the main thing of the programming, so I will discuss this in details later. So, and the last mode, as you can see, the copy mode. What is the copy mode? What we will do in the copy mode? In copy mode, suppose you have 3 drives. Okay, if you have 3 drives, let me draw something. If you have 3 drives, suppose drive 1, drive 2 and drive 3, you have 3 drives. So just program this first drive. Okay, you don't have to program this 2 and 3, just program this first drive and copy this all the parameters, all the programming to 2 and to 3 also. So by this way you can save your time. Okay, so in copy mode we are copying the parameter, in the parameter copy mode we can copy the parameter and paste it to the other drives, so we can save our time. Okay, let's move to another. This will show, you can read this manual, how to upload and download parameters, means how to copy from a drive and how to paste it to the other drives. So it will show you the process how we can do. Okay, application macro is there. So in ABB there is a application macro is there. Application macro means for what purpose you want to use your drives. Okay, there is lots of macro is there. Macro means already programmed macro is there, just you have to select for which purpose you want to use your drive. Like default one is ABB standard. Okay, in ABB standard ordinary speed is there. Okay, means there is no constant speed selection, means neither low, medium or high speed is there, only ordinary speed is there, through which we can select from the potentiometer, means from analog input 1. Okay, same like there is a 3-wire alternate. Okay, if you want to run your motor in forward and reverse also, you have to go to alternate, you have to use alternate. If you want to use your 3-wire stands for if you want to use your motor in 3 speed. If you press first button it will run 30% speed, second button 50%, third button 80% or 100%. If you want to use as a 3 speed you have to select 3-wire. Okay, same like motor potentiometer, if you want to change your speed through the potentiometer you have to use this. So I will explain you. If you want to use for PID, constant PID control means pressure control. If you want to make your drive with a pressure control, okay, if you want constant pressure you have to go for PID. PFC and SPFC control are a special control for the pumps and motor. PFC stands for pump and fan control. If you want to control your fans or pumps you have to go for PFC, and SPFC just an upgrade version of PFC. Okay, and there is a 2 more, user and ACS 500. User means you can make your own macro, you can program from your own. Okay, and the ACS 500 if you want to control your device from a PLC. Okay, if you have 2 or more device and you want to control it from RS485 communication, you have to go for this ACS 500 Modbus is there. Okay, so as you can see here, this is the summary. Okay, summary I will explain you, so it will be better for you. Summary for the application macro. Okay, see ABB standard. So from analog input frequency reference is there. Okay, this macro, first macro ABB standard means if you apply 0 to 10 volt in analog input 1, based on this frequency, okay, based on the voltage it will increase the frequency or decrease the frequency. Okay, there is no AI2 used in this macro. Okay, analog output for output frequency. Okay, means we will get the frequency from this pin. Okay, DI1 for start stop. Okay, DI2 is for forward reverse, DI3 constant input 1, DI4 constant input (2) and ramp pair selection is there. Okay, RO for fault -1, fault -1. See this RO and this DO. This is the normal relay and this RO is a 24 volt transistor relay. Okay, so from this summary you can check which macro is suitable for your need. Okay, here you can see also they explain all the macros here. See, for the default macro you can see they used AI, ground, 10 volt, and there is a potentiometer over here, this potentiometer. Okay, from this potentiometer you can vary the speed of the motor. Okay, from this pin See, these pins are empty. Okay, from this pin we can get the output, frequency output. Okay, from 0 to 20 milliamps. Same way, the first one is start or stop, forward, reverse, constant speed is there. Okay, both relay are for fault -1. I will explain you what is fault -1 later. Okay, from 3 wire macro you can see what they have done. There is a frequency for AI1, okay, ground and 10 volt, through which we can vary the speed from vary the speed of the motor by supplying 0 to 10 volt. Okay, and from this pin we are getting the output frequency, and here you can see first one is start, okay, second one is stop, third one is forward and reverse, okay, fourth constant speed 1 and 5 constant speed 2. So this is the macro. Alternate macro, here you can see start forward, start reverse, constant speed. You can read this thing from the manual. You can download this manual from the Google. And let's move to this. This is the PFC. Okay, PFC. Let me explain you PFC a little bit. Here you can see external reference hand, external reference PID PFC 0 to 9 volt. Okay, this 1, 2, 3. Here 1, 2. See, okay. From here you have to connect whatever output you want. Suppose for PFC we want a 6 bar pressure for our booster pump. So what we'll do, we'll connect here, or we will connect here potentiometer, and through this potentiometer we will supply suppose 10 volt. Okay, so we already supplied 10 volt. So 10 volt means 100%. Okay, in case of VFD 10 volt means 100%. And this is the sensor. Okay, this is the pressure sensor. We will connect the pressure sensor in analog output too. So in pressure sensor, what it will do, in the pressure sensor we will get the voltage. So the value of the pressure sensor is between 0 to 6 bar. So if there is 0 pressure, we will get 0 value. If the pressure is full in 6 bar, we will get 100%. 100% means we will get a 10 volt. So we have to connect the pressure sensor here, through which we will get the actual value, and whatever desired pressure is, we will connect to analog output pin 1. So this is the PFC. See, this is the PFC. Okay, this drawing is for PFC. Okay, you can see over here there is 2 or 3 motors there. Through one motor, okay, second motor, okay, third motor is there. So you can get this drawing from this manual also. If you want PFC control, okay, you can follow this drawing. Okay, let me move to parameter. This is the parameter. Okay, short view parameter. Okay, short view parameter. Let me explain you. If you want to manipulate the relay, means for relay what purpose you want. Okay, if you want relay when the motor is tripped, if the motor is running, then you want to actuate its relay. So you can select the condition when you want your relay to be active. Okay, from this parameter 14 group you can set the relay. From 18 you can set the second relay, that is transistor output. From the 11 reference select is there. Okay, as you can see, define the maximum value for external reference 1. Okay, from this you can set the reference value 50 Hz or 60 Hz is there. Okay, so let me move to parameter in details. Okay, this is the parameter is there. So as you can see, first one is operating data, means basic signals for monitoring in drive read only. Okay, what you want to see, means the basic signal for monitoring. Okay, let me move to next. Okay, for the relay, for what purpose you want to actuate your relay. Okay, for in my case, when the motor will run, I want relay to be active. Okay, so what I will do, I will set 1401 in run mode. See, because I want to actuate my relay when the motor is running, so what I will do, I will make 1401 relay output 1 as 2. If I set as 2, when the motor will run, the relay will get actuated. Okay, in your case, if you want your relay to be active in fault case, suppose there is a fault or trip is there, then you have to set as 3. So what I will do, for relay, this relay, for the normal relay that is 250 volt, we will set as run 2, and for the other relay that is nothing but the 18. Okay, let me show you the 18 also. Okay, for this 18, what I will do here, 18, we will set this 18 relay, means this is normal, not normal relay, this is a transistor output relay. So what I will do, when there is an alarm or fault is there, I want to actuate this relay. So to use these pins as a relay, what you have to do, you have to select 1804 parameter, how gonna use this relay pin. So I will set as a digital. Okay, if you set as digital, it will use as a digital output, but if you set as a frequency, it will use as a frequency output. So in my case, I will use as a digital. Okay, and the 1805 I will use as a fault minus 1. Fault minus means what? Fault minus 1 means this: when relay is energizes on trip, okay, de-energizes on trip. Okay, so when the motor is tripped, it will actuate the relay also. Okay, and let me show you 34 also. 34. So 34 group parameter is for display purpose, means in the display we can set three values. We will get three values. Okay, whatever we want. Suppose we want to see every time frequency, what is the frequency, what is the amperes taken by the motor, what is the output, what is the feedback is there. So we can set three values here. Okay, so as you can see, signal parameter 1. So from the 3401 you can set the output mode is there, means output, whatever output you want to see in your display. So by default there is the hertz, ampere and output feedback is there. So I will show you how you can change. Okay, see, as you can see, the parameter signal 1, signal means first value they set as 103. 103 means what? So you can see come down and check what is 103. Let me show you. Okay, 103 means frequency. Okay, let me show you. Okay, see here, 103 means frequency. Okay, 104 means current, 105 means torque. By default these three are selected: output frequency, current and torque is there. Okay, but if you want to change this, you can select anything. Like if you want output voltage, you can select 109, so it will display 109 output voltage. Okay, if you want to kWh counter is there, you can select 115, so we will get the kWh value. Okay, runtime 114, PID value. If you want any other value other than the default value, you can set whatever you need, you can set from here. Whatever value you want, you can set from here. What is the actual signal is there. Okay, that is nothing but parameter 1. Okay, so let's move to 34. So in the 34 we can select whatever value we want to see in the display. So in signal 1, see, 103 is selected, means current is selected. Okay, signal 1, and when you come down, you will get the signal 2 as well. Let me show you. See, signal 2, 104 is selected by default. Okay, same like in signal 2, this signal 2, 104 is selected by default, and in the signal 3 here, in the signal 3, 105 selected is there. So whatever value you want, just go to 3415 parameter and change this 105 to any other value, whatever you want to see in the display. Okay, so let's move to other parameter. 99. Okay, 99 parameter is startup data. Okay, startup data means you have to set the motor data in 99 parameter. Okay, 9901 you have to set your language. Okay, if there is a English, Chinese, Korean, Japanese, French, there is lots of options are there. So by default it's 0. It's selected as a 0 English. Okay, if you want to set any other language, just change this 9901 to any other value. Like for 0 it's British English, for 1 American English, for 2 German, for 4 Spanish, for 5 Portuguese. Okay, 9902, this application macro, you have to select your application macro. Okay, by default ABB standard is there. If you want to use as a PID, select the other. Okay, if you want to see, by default it's selected 1, means ABB standard. If you want to use PID, you have to make it 6. If you want to use 3 wire, you have to make it 2. Okay, let's move to another. 9905. Okay, this is the motor nominal voltage. You can set any voltage of your motor. So in my case 400 volt is there. Okay, 400 volt is there. Motor nominal current. What is the maximum current for your motor? You can check this detail from the nameplate of the motor. So set the motor current, like in my case 2.2 amperes. Motor frequency, in my case 60 Hz or 50 Hz, but in my case it's 60 Hz. You can set any as per your motor. What is the motor nominal speed? You can set the speed of the motor in RPM, like in my case I think 1500 RPM. Motor nominal power, that is in my case 2.2 kilowatts, so you can set the value in kilowatt. Okay, and the phase inversion is there. Phase inversion means, but if your motor is running in reverse direction, so what you have to do? You have to make it 1. If you make it 1, your motor will run in forward direction. So I explain all the things from my side, but if you need any help regarding this manual, the comment, I will reply you on this. I will explain you all the things in field side also. So let's move to field side. Thank you.